Hello, my name is Li Xin, a visiting PhD student at the board, and my major is ecology. But before I come into Copenhagen, I prefer to combine the ecologic and the geography, and focusing on the spatial distribution of the plant function trees. My research focuses two topics. The first one topic is using the stoichiometry to predict and explore the ecosystem function, such as the ecosystem productivity. And another topic, I wanted to explore the relationship between the nitrogen fixation and the stoichiometry in mosses. The two topics allows me to work beyond the indoor or outdoor. In the field, I needed to collect the plant samples, and I also obtained the structure and community structure data. And in the laboratory, I also needed to test the nitrogen fixation and the nutrient content. And then I also needed to do some analysis for the collected data. My current research focuses on the second topic. My group member collected the same mosses species from different climate zones, such as the tropic, the temperature, and the Arctic climate zones. And I cultivated the mosses in uniform conditions, and the changes of the stoichiometry and the natural fixation will be observed after 6 months. And the goal of the research can be summarized as follows. The first one, I want to know the variation of the stoichiometry and the natural fixation in mosses and in different climate zones. And the second two, I also want to find out what is the main factor driving the variation of the natural fixation and the stoichiometry. Is driven by the evolution of the species itself, or it is driven by the external environment. Yeah, it's worth to explore it. First, mosses are everywhere, from the cold polar to the steamy rainforests. Yeah, we all can see the mosses, and the mosses like a little environmental sensor. Yeah, it can reacting to any change around them. Yeah, and it also can combine with some cool bacteria and turn the air nitrogen into the plant food. About the stoichiometry, why bother with the stoichiometry? Yeah, maybe we can think in this way. Everything in the nature is made up of the elements. The elements move around a lot, but they don't disappear. By studying the balance of the elements in mosses, maybe we can track how the nutrient flow through the ecosystem, and it better help us to understand the natural fixation and the other related functions. Stoichiometry is a term and comes from ancient Greek. A German chemist was the first one to discover and created this word. It's about measuring the amount of elements that go into or come out of a chemical reaction. But in ecology, the stoichiometry is about how plants are made up of elements and how the balance of environment affect the way of work. It like looking at a recipe for plants, see how much of its ingredient there is. Yeah, in addition to some basically library method and statistic method, I mainly use the random forest. I use the random forest mainly to find out what is the main factors driving the variation of the nitrogen fixation and the stoichiometry. I think the random forest is very awesome because it can handle a lot of data and a lot of factors. It also can give me accurate result, and it also can tell me which factors is most important. I'm very sorry because my story of the knowledge is not enough to answer this question, so I can just briefly talk about my future research direction. Yeah. In the context of the climate change, maybe we should to pay more attention on the response of the Moses function and the Moses trace to the climate change. I'm interested in two topics. The first one, maybe we can assess how different species contribute to the nitrogen fixation, the ecosystem function, and the other traits under the climate change. And another one, maybe we can develop some models to predict the Moses nitrogen fixation and the Moses stoichiometry in response for the climate change. Thank you. Bye.